Welcome to the notes on triangle properties. So let's take a first look at this first one. All right, triangle side lengths versus angle measures. Basically here it is, larger the angle, then longer the opposite side. All right, smaller the angle, then shorter the opposite side. That's pretty much it. Okay, so let's take a quick look at an example. It says, write the measurement of the triangle in order from least to greatest. So if we want the least, we got to look for the smallest angle. So here's the smallest angle. Which side is opposite from that or across? It's BA. So we're going to say BA, segment BA, that's obviously the smallest angle. All right, then what's the next smallest angle? Well, that's 57 right here. Which side is across from that? Right there. So we're going to say BA is obviously less than, what's the name of that segment? That's segment AC. And then that's going to be less than, where's our largest angle? Right here. And what's the name of it? The side opposite of it or across from it? That's segment BC. So there is a that's writing them in order of least to greatest. All right, now let's do the same thing. Now they give us the side lengths. We're going to do the angles. So if we want the smallest angle, we got to find the smallest side. So here is the smallest side. Which angle is across from that? Well, that's angle E. So we're going to say angle E, and that's the least. So it's going to be less than. What's the next small size? Well, that's 13. Which side is across from that? Well, that's going to go with D. So angle is less than angle D. And then which angle is left? Well, 22 is our biggest length, so that's got to go with angle F. So less than angle F. Oops, so less than, that's the angle sign, F. All right, in black, those are inequality symbols. So that's listing them from least to greatest. All right, larger the angle, longer the side. Shorter the angle, shorter the side. Or smaller angle, smaller the side. Here we go, triangle inequality theorem for the sum of the lengths of the three sides. Basically, each side, when you add up the two sides, has to be greater, not equal to, greater than the length of the third side. So pick any two sides, has to be greater than the third. So they'll ask the question, can a triangle have sides with the given lengths? There are the lengths listed. So let's add them up. Let's do the first, is 5 plus 15, I'm just picking two. I'm going to do 5 and 15. Is that greater than 10? Yep, 15 is greater than 10. So those two work. Let's do 15 and 5, or 15 and 10. Is 15 plus 10 greater than 5? Well, obviously 25 is greater than 5. Now let's pick the two shortest sides. All right, these are the sides you always want to be careful of. Is 5 plus 10 greater than 15? Is 15 greater than 15? No, it's not. It's equal to. So can a triangle have, it cannot, all right? No, all right, because the two shorter sides is not greater than the third side. Pick any two. They all have to work. Watch the two shorter sides being greater than the third. All right, a couple more properties. The hinge theorem, all right, or the side angle side inequality theorem. Here's a visual of a door hinge, which I like. Again, why do we call it side angle side? Because it says if you have a triangle with two congruent sides, 3, 3, 3, 3. All right, you can see those right here, 3, 3, 3, and 3. And the included angle is not congruent. Then the smaller the angle, the smaller the opening, as you can see in this first example. The door doesn't open very wide, smaller opening. Here, the door opens much larger, it's a larger opening. So when you have two congruent sides, depending on the measure, the included angle will depend which opposite side is greater or smaller. So here's a quick example. Which inequality relates ln and segment ln to OQ? Well, here's our two congruent sides, 4 and 4, and then we've got our 7 and 7. So there's our included angle. This one right here is greater than 78. So we know that this opening must be longer than OQ. So we're going to say segment ln is greater than OQ because that included angle is greater. It's that easy. Let's take a quick one more problem. This one involves some algebra. Now, what is the range? Those are all possible values of x. So you look, here is our congruent side, all right, and we have the reflexive property. So there's our two included sides, or two congruent sides, included angle. Well, if I want to find x, I know that since 15 is greater than 10, I know that 5x minus 20 has to be less than 60. Okay, then we just solve for x. So let's just add 20. Add 20. So 5x, oops, let me go blue here. 5x is less than 80. Divide by 5, divide by 5. All right. So x is less than 16. Okay, now one more. Now the other range. Now this angle, though, also has to be greater than 0, because you can't have an angle that measures 0. So this is the key part that you have to remember. So we've got to also say that 5x minus 20 is greater than 0. So we're going to add, now it's a simple problem of getting solving for x again. Add 20, add 20. So you have 5x is greater than 20. Divide by 5. So x is greater than 4. So here are our two solutions. X is greater than 4 and x is less than 16. So you can write it like this. You can just write x is greater than 4 and x is less than 16. Or some people will write it like this. You'll put x in the middle. So x is greater than 4 and x is less than 16. You can also write it like that. There is your lesson on properties of triangles.